my channel, Code with Fernando. In this video, we are going to talk about reactive error handling and termination. So, introduction. We know that errors are part of the data flow. They're not thrown. They remit as signals and must be handled without breaking the stream. What are some key topics that we are going to talk about in this module? We are going to talk about how reactive signals work. We have unsubscribe, on next, on complete, on error. There are 4 in total. Next, we are going to talk about how errors propagate through streams. After that, design principles for handling error reactively. Finally, we're going to talk about common strategies such as on-error resume, on-error return, and do on-error. Okay, understanding reactive signals. So, what are reactive signals? Okay, they're the core communication mechanisms in reactive programming. So they allow data and events to flow between components. These components are the publisher, subscriber, and processor. Some key points to remember. Defined by the reactive string specification. We have already seen that before. Okay, in video 1 or video 2, I think. And then we have ensure predictability, safe, and asynchronous data flow. Control the stream's life cycle and state transitions. So what are the type of signals that we have? We have 4 in total. The first one is unsubscribe. This one establishes the connection. Then we have on next, emits a data item. Then we have on error, signals a failure and terminates the stream. Finally, we have on complete. This one signals successful completion of the stream. So understanding these signals is essential for writing clear and correct reactive code. So what are reactive signals? Okay, reactive signals are events. Okay, this is really important. Events sent from the publisher to the subscriber. So this is really important to understand. So reactive signals are events sent from the publisher to the subscriber. They define the full life cycle of reactive data stream, from subscription to completion or failure. One of those two, completion or failure. Okay, so let's see the 4 core signals. The first one, unsubscribe. Okay, this one is set once when the subscriber connects, only once at the beginning. Sets up the stream and allows the subscriber to request data. Okay, then we have on next. On next, this one is emitted for each new data item. This one can be called 0 or more times. This one is not terminal because the stream continues after that. Then we have on error. Indicates a failure in stream processing. Immediately terminates the stream. No further signals sent after this. So it's like a final operation. Okay. Then we have on complete. This one indicates successful completion of the stream. Terminal signal. No more data will be sent after that. So every stream starts with an unsubscribe and ends with either on error or complete, never both. So depends on the case, we are going to choose one of those, okay, on error or complete. So what are not reactive signals? Okay, this is very important to understand also. Not everything in reactive code is signal. Some part of your code build or trigger a stream, but they're not signals themselves. So examples. These are here we have some examples of NOC signals. When using operators like map, filter, or flat map, okay, these ones define how data will be transformed. NOC signal like anything directly. Okay. Also calling subscribe triggers the stream, but isn't a signal. It's just starts the flow. Okay, then we have emitting values manually, just like using just or from supplier. Okay, internally causes signals, but the act itself is not a signal. Okay, stream construction and pipeline setup. So this is not part of the signal flow until a subscriber subscribes. So what are the importance? Okay, they're important because they are the foundation of stream behavior. They give a structure, safety, and control to a synchronous data flow. Okay, here we have some key reasons to remember. Okay, they're important because they control the life cycle. Okay, signals define how stream starts, flow, and ends. backpressure compliance, subscribe and request. Let the subscriber control the base. This is really important. Let the subscriber control the base. Okay, prevent overload and improve system stability. We have already seen this before. Back pressure. We know what is back. We know what back pressure is. Then we have error handling. On error delivers failures through the stream itself. No need for traditional try-catch blocks. Okay, in reactive programming we don't use try-catch blocks. Okay, later we are going to see some examples of how to use on error. Okay, predictability. Every stream follows a strict, well-defined contract. First we have unsubscribe, on next, or complete, or on error. Okay, some important rules to remember when using reactive streams. Okay, reactive streams follow a strict contract to ensure safe and predictable behavior. Okay, these are the rules. A stream starts with an unsubscribe. Okay, this is very old. This happens every time, always. It starts with unsubscribe. This sets up the connection and allows a subscriber to control the flow with requests. So whenever we get the next item, we need to use this method request. And here we pass as a parameter how many items do we actually need. Then we have only one terminal signal allowed, either on complete or on error, never both. So we need to use only one of those, on complete or on error, never both. Okay. No signals after termination. Once a terminal signal is sent, the stream is finished. No more on next, on complete, on error allowed. Okay, let's continue with our code example. First, we are going to create our publisher. Our publisher is going to be about books, as usual. Okay, this one would be a stream of books. So, how do we do that? Let's use flags. Type string. Oh, okay. String. Let's call this book publisher. Books, and then flags just book a book 1, book 2, book 3, finally book 4. Okay, after that what do? We need a subscriber, right? So we need a subscriber. What does a subscriber do? So this guy is going to defines how to handle signals. Okay, so what do we do? Books subscribe. Okay, then we pass as parameter a new subscriber of type string. So in here we have all the signals: unsubscribe, on next, on error, and finally on complete. Okay, first we need a subscription. Okay, so we are going to here write subscription. Okay, then we are going to, this subscription will be equal to this one. Okay, then what do? Okay, and here we are going to just print unsubscribe, because we are in this method, right? This signal unsubscribe and subscribe to the publisher. Okay, that's it. Then what do we do? Okay, then we need to request a book, right? So we're going to request subscription request long max. Okay, then we go to the next signal, on next. So on next we are going to print the book. Here we are just going to print the book. This is on next, and this one receive the book. Okay, let's call this book. Okay, mistake here. Okay, this on error. What do we do here on error? Okay, let's just print here on error. This is our signal on error. Then we are going to print the message and get message. That's it. Finally, an incomplete, and here we are just going to print incomplete. We don't need to print no more, right? All books received. Okay, that's it. This is the flow. Let's print this. Okay, let's wait. Perfect. Unsubscribe here. That's why we see this subscribe to the publisher. Okay, then we are requesting. Okay, we are requesting one book. That's why we see on next. Book 1, book 2, book 3, book 4. Because of we don't have any errors in here, that's why we see the incomplete. Otherwise, we'll be seeing this error. We know that we only should see only one, just on error or maybe incomplete. Only one. We have never going to see both of those in action. Okay,